Hello, thank you for joining us for another podcast. Today we'll be talking about automated defect detection. In this episode, we're going to explore the transformative impact of advanced technologies, what AI and machine learning brings in to the edge to really have a tremendous impact on defect detection, increase profitability, and increase product yield. My name is Mondo Mikhail. I'm your moderator, a senior solutions architect with ADLINK. Today, I've got a very interesting speaker with us today, a guest. His name is Ryan Vanderwerf. He's a senior product solutions architect with Amazon Web Services. His focus is primarily on industry partner solutions and manufacturing for the Americas. Hi, Ryan. Thank you very much for joining us today.
Thank you, Mondo. Glad to be here.
All right. So today, like I said, we're going to be talking about a really interesting area. I didn't know a great deal about it. That was AI and ML powered, but it's defect detection and how Amazon Web Services really brings those services directly to the network edge and how they've really changed the way that manufacturing is done and how quality control greatly is increased. So without further ado, let's get started. So defect detection, Ryan. Like I said, I wasn't really well versed at this before we began formatting this podcast. I'm very interested in delving into this topic. Help us understand what is defect detection and how it's really implemented in the context of manufacturing. Give us a little bit of historical perspective, just briefly, what it's been done primarily in the field and how AI and ML are really taking this forward and giving greater efficiencies.
Yeah, absolutely. So a little bit of the history was the visual inspection systems have been around for 30 years. They were traditional rules-based optic systems with cameras looking for defects. Often those would go to people to inspect images, or they would follow a very strict set of rules of trying to measure something on a camera or looking for certain spots, whether a bottle cap is present or not. And those things are still used today, especially in high-speed, low-margin areas like food production. For example, a bottling line, where things are moving by very quickly. Those systems are still used today. They're fairly low cost. However, it is expensive and time-consuming to set up all of these rules. And if it's something that has a lot of variance to the product, maybe the surface has all kinds of anomalies, or it's like a snowflake pattern, like, for example, metal engine blocks. These things are very difficult for a rules-based system to look at and give some sort of answer is there problems with this or not? So that's really where the deep learning and AI has come in, is we'll look at these primarily surfaces of things, but it could be metal parts, it could be packets in food that are missing or not, or scratches on vials, for example, in drug production or anything like that. And it becomes very hard and very time consuming for a person to have to look at these for an entire shift and get a consistent answer. My friend Tim here likes to say these dull, dirty, and dangerous jobs that a lot of people aren't really interested in doing, and they have high turnover and a lot of training. And sometimes it's very subjective. Say finish a wood panel on an airplane is a very difficult thing to find defects on visually without special training. And a lot of those companies have difficulty retaining those types of people. So deep learning is really good at these kinds of use cases where there's a lot of variance to it. And it's just something that's tough for a rules-based thing to do.
Right. Thinking back in the past, a lot of people, were watching TV and so forth. Suddenly a newscast will come on and say there's a big recall either in a airbag system in a car, some kind of braking system, also product defects that are found. All of these take enormous amounts of time and dollars to recall the product, bring them back, do any kind of engineering redesign so they're made safer, perform better, and then redeploy out in the field, not to mention the cost of actually having to redo this and the inconvenience of the customers. And when I think of Amazon Web Services, I know it's this immense compute technology that's cloud-based. And people understand what Amazon is, the amount of data that they can gather and the amount of AI and machine learning that can be done. But specifically for defect detection, how are Amazon Web Services and the compute that you guys have deployed specifically for defect detection, and what do the innovations of artificial intelligence and machine learning really bring to the table?
Yeah, absolutely. So we have a service called Amazon SageMaker, and it's our base platform for most of our machine learning, where data scientists can work and train models and work with notebooks in Jupyter and do all these things. And the power AWS brings is that we have a lot of GPU available in the cloud. So when we need to train models, we can do that on a pay-as-you-go basis. So if I need to train a new model, I can spin up as much compute that I need, quickly get a training job done, and then release those resources back and only pay for what I used. Traditionally, if people wanted to do machine learning locally on premises, they would have to buy all of that compute and have it all year long turned on and bear the brunt of that cost all the time when they only need it for a few hours. And then at that point, deploying via the edge, via our services like AWS IoT Greengrass, we can deploy these models and code out to the edge devices, for example, on ADLINK devices, run inference in real time with GPU acceleration just needed for that, which is a much different kind of need than doing training. So that just becomes a lot more affordable to the user, and then they can get that edge speed and performance, low latency, data sovereignty, and all these things that really help.
Right. Let me ask you this. For AI and ML, a lot of people aren't really versed in that, but to my knowledge, you need massive amounts of data to develop a model. Now, for all these different kinds of defects, whether they're manufacturing automobiles, the example you gave before, wood grain going into the paneling of an aircraft, how do you first collect that data from the customer in order to run your AI and ML models? How difficult is that to do, and how much customer involvement does that require?
Yes, that is the most difficult part. Often customers say, I'm having these defects, but I don't have exact examples to show you. So in a situation like that, we can either manufacture some defects, or we can use tools like Gen AI. For example, Bedrock Titan models, we can actually try to generate anomalous data, like adding scratches to the surface of a perfectly good looking unit, and add that to the training data so we have a model to start with. And also sometimes when we deploy these systems, we'll deploy them in like a shadow mode initially and collect data and just observe. And then once we've built up a good data set, we can train the models or retrain the models in a few iterations and then get them to the point where they're satisfied with the performance of what it's detecting.
Okay, and the final model you feel is accurate enough with some data that you create versus data that the customer provides? It's really a deployable model and really does what it should be doing?
Yeah, absolutely. And some of the modern models can do this thing, sometimes less than 100 images of training. Some of the old models would require thousands of images, which really isn't practical for customers to try to gather anomalies on. So we can get a good model going with a few hundred images and have something that's pretty satisfactory to the customer. And it depends on what it is and how subtle the things are with it. We can always use other technologies besides just regular cameras, things in non-visual spectrums, shortwave infrared, or laser displacement sensors to analyze surfaces and then train models against that, which we've done in the past as well. So it's not always things that you can see with your eyes, but maybe something that a machine or sensor can see with their eyes.
Okay, a lot of people hear edge computing. Edge computing seems to be the biggest buzz right now. And you said these models are being trained on Amazon compute engines using GPUs up in the cloud or back at the Amazon centers. Today, there's smart cameras being deployed in the field, smart sensors, smart computing. All of them tend to have some vision aspect of them. When the model is created and you get a real inferencing model that can be deployed, is this deployed actually at the edge where the data is taken, or can the data still be funneled back in the cloud, processed there in real time enough to actually give you some accurate results in the time frame the customer is looking for them?
Yes, most customers prefer to process that data locally. So we'll train in the cloud, push those models and any of that software that runs in the edge device, manage that from a central place in the cloud, say a fleet of devices, push all those models out using tools like AWS IoT Greengrass. And at that point, it's running locally on local compute and doesn't need an internet connection. A lot of customers feel better about that because A, they want their data to stay maybe on premises, but it's also the latency. We're talking about something that needs half a second or less response time to analyze an image. And going to the cloud and back for that isn't necessarily a practical thing, especially when you're doing it at scale and you're having a lot of video or image traffic going back and forth. It just exasperates that problem. So things like the DLAP devices or the Neon smart camera, they have enough compute in them now where you can run AWS IoT Greengrass and running these models with tools like NVIDIA Triton, and we can run all of those things at the edge. And you need much less compute to do that than you do to train data. So the cost is more palatable to customers running it on-prem. And of course, they can always go back to the cloud and do that if they'd like. It's always an option. And we do that for prototyping. So before they spend money on hardware, we'll try it out, do the feasibility, and then start putting together a pilot with hardware as the next step after that.
All right, let's say I'm heading up a manufacturing effort on a factory floor. I start to employ the Amazon Web Services defect detection on my edge devices that I have out on my manufacturing site, the vision-based devices. I run these. How much knowledge would I have to have as the head of manufacturing to be notified of these defects, or does that data go up to Amazon? Then there's a report that's generated that gets back to the manager of the manufacturing floor. How much control at the site does the individual or organizations have to manage that data, then be proactive enough to make decisions on it?
Absolutely. They have complete control of the data. There's simple dashboards built in. Currently, you can see at this line level. And then that data going through services like AWS IoT Sitewise and our IoT core services, that data and metadata telemetry, not just the images themselves, but the disposition it's finding of the products and maybe identifying the products can be sent up to the cloud. And then the customer can say, build a data lake with that and get long-term insights across all their lines and all of their plants. And then suddenly now you've got a story of which plants are performing well, which ones maybe need some maintenance because their defect rate's becoming very high. You can get this level of insights, bringing that OT world into the IT world.
Ryan, I know that data security is huge. Cybersecurity is on the forefront of everybody's mind. We keep hearing these instances in the news where it wreaks havoc on an organization. It costs them millions of dollars. Everyone is afraid or thinks paramount about security. How can Amazon Web Services really guarantee security and reassure their customers their data is protected and there's no breach in their organization?
Yeah, great question. First of all, we take security as job zero at AWS. And one thing to keep in mind is AWS really is architected to be the most flexible and secure cloud computing environment available today. That means our core infrastructure, we built this to satisfy the requirements for military, global banks, other high sensitivity organizations. And our infrastructure is monitored 24/7. We have multiple fault isolation capabilities to improve resilience. We also allow encryption of all the data at rest. You can use your own encryption keys that even we don't have access to, and only you could decrypt your data. So, and this is really backed up by a deep set of cloud security tools. We have over 300 security, compliance, government services, and features. In addition, we support about 143 security standards and compliance certifications, including things like PCI DSS, HIPAA, HITECH, FedRAMP, GDPR, FIPS 140, NIST 800, 171. And all these things really help satisfy compliance requirements for almost any regulatory agency around the globe. So we're really equipped to handle those kinds of things with all of our tooling and security things to make sure that people have that top of mind and that they can have some reassurance there.
That should reassure a lot of people. One other thing that I was thinking about, once you have this data, all this data is collected, it's turning away in your organization, your defects are being reduced, quality is being increased. But once you have this data, it's a huge knowledge base of your processes and your manufacturing workflow. How can this data be used in other means to give insights into your organization and your manufacturing processes?
Yeah, absolutely. It's great question, because we can take all this data, and a lot of it's coming at a line level, right? We're expecting individual lines, we're looking for defects, we have the metadata of that. Automating all of these things is a huge secondary benefit with all this data that you're gathering. And now you've got traceability throughout the whole process. You have the images of where anomaly may have occurred. You can catalog and save all this metadata into a data lake. And using services like AWS Sitewise, clients running at the edge, we can be funneling all of this data back to the cloud and get really good insights, reports, dashboards with our data and analytics services, things like even Amazon QuickSights, Redshift, all these types of things, or even third-party tools that are AWS partners can really help you derive insights and navigation. You can also combine this with other data like operational excellence, talking about asset condition monitoring. And maybe you could vector things together with if equipment is vibrating or using too much current, or there's failures going on in that way, we could piece that together with a greater picture of, well, we're getting anomalies because maybe there's some equipment's gone wrong and needs maintenance or replacement. So having data sources from multiple places put together in a data analytics package could really give you the overall view and also help you with root cause analysis of what might be causing issues and quality problems.
Right. Now, with this data, is there a point or on a regular basis that this data is fed back into the model to increase its accuracy?
Absolutely. So some of the tooling that we have currently running at the edge allows operators to flag things if it's of low confidence, and they can flag that as hey, we want to add this back into the data set. So the next time we go a round of training as a periodic maintenance, we can reinforce the models if it's unsure in certain areas and reassure it's that it is sure in other areas. And then over time, the models get better and better and more accurate for different situations. And you also may have changes in your environment or lighting or time of day, or maybe someone slightly bumped a camera and it's just a millimeter off. Those kinds of things of having that tuning data periodically to make sure things are performing well is important for health of the pipeline of checking for quality.
Right. But from a user perspective, is there a dashboard or is there a visual metrics that the manufacturing floor managers gets to see so they can really monitor the process?
Absolutely. So some of the tools that we use have that built in, and some third-party partner tools also have, again, this data is brought back to the cloud and you're giving you insights at that level. So we have both at an immediate dashboard level, and then analytics packages can help you get that greater picture at a higher level.
Perfect. Well, one interesting thing I was reading about AI and data breaches is AI is as good as the data that's used to generate the model, and just having some assurance that data set isn't being compromised and the model is not giving you inaccurate results, I'm sure really brings a lot of ease in the organization's mind. That's just very interesting to consider when you're implementing this. Now, the big question is, I'm a customer, let's say, I'm thinking about implementing this. I believe it's a real benefit. What type of metrics can you provide to me to say, if I go through the cost and expense and the time it takes to implement this, how much money will I save? How much more quality can I input into my products? And is this a good investment for me?
Sure. And one of the original asks that we do when we work with customers is to calculate what is the ROI value here. Before we get into metrics of how well are human inspectors handling looking at things and catching defects, we want to know those when we're comparing to know we're getting a net increase or gain. But also we need to understand what the ROI is, because the types of equipment you use directly affect that. If I'm using a $25,000 camera, that might not be appropriate for the use case, and there wouldn't be really any savings. And typically we find if the ROI can be paid back in 2.5, 3 years, maybe tops, the project's worth doing. And sometimes, depending on how much scrap or rework they do, sometimes that's a big factor for some customers where 20% plus savings can happen there. But sometimes also there's regulatory penalties that are very harsh, especially in Europe. If, for example, an allergen got into a food product that's not supposed to be there, some of these fines are very large. And it behooves companies to be able to use these inspection systems with vision. And there's also a record of everything that's happened and every image it's looked at. So versus someone kind of looking at that on the line going by, they can go back and have a history of all these results and say, okay, we know something bad got out here, and we can track it back to this point in time into this exact line and know what that looked like. And that's a very powerful thing to have when you're in a regulated type of environment, say pharma or food situations.
Ryan, this seems like really incredible technology. I mean, AI and ML bring some tremendous insights into defect detection. Help us understand, where is this heading, with Amazon Web Services? You've given us a great snapshot into what's happening today, but what does Amazon Web Services plan as moving forward to enhance the service?
Well, there's a lot of technologies that are growing and getting smarter by the day. And that includes new kinds of models are being developed all over the world, and running those things on Amazon Bedrock services and things like that. These Gen AI models are really a lot of the future areas where we're looking for things like zero-shot models, less and less training being needed. Some of the Gen AI tools can help with describing and prompting and then adding anomalies or detecting anomalies in that way with less training needed. And that's kind of the future, is to make this thing find the defects in the lowest amount of pre-training possible. So data scientists are hard at work all the time, getting these models better, requiring less data up front. And even in the last 5 years, we've had huge leaps of the amount of data models needed to train and get good results is getting lower and lower. So the dream is for people to get to almost a zero-shot model where it doesn't require a lot of guidance at all, and it's just ready to roll immediately.
Right. Well, what you're talking about is generative AI.
Yes. And then that's this generative AI, we can give examples of what good things are and then bad things are, and then can take that. And some models like Claude 3 and things like are getting closer But still, for having that level of defined detail, I don't think we're quite there yet. But I think in the next year or two, things are evolving so quickly, so we may get there sooner than later.
Perfect. I know recertifying a product is enormously expensive and takes quite a bit of time. That can really be a huge cost savings just from that. You brought up some interesting points for defect detection. You certainly sold me. So if I, as a customer, would be interested in starting this, how would I reach out to Amazon? How would I get started? Is there prototypes available? What's the best way of moving forward with this?
Yeah, we have several options. If you're an existing AWS customer, I would contact your current account manager, and you can ask for someone like me to be brought in as an expert to help with the opportunity and solve the problem. And that's probably the most efficient way. You could try to also reach out to me, but having your account manager be involved would be the best route to doing that, because then the account manager has programs available. They may have some sort of funding to help you do pilots or POCs that they can help you with. And so you definitely don't want to miss out on all these opportunities to get help getting this off the ground, because we have a lot of programs available and the account managers are always up to speed on what those are. And there's a lot of opportunities to get help.
Right. This has been a really interesting discussion. I know preparing for this, I learned a bit about defect detection, but just having this discussion, I learned so much more. Ryan, I really want to thank you for joining us today. It's been a fantastic discussion. I'm hoping all the listeners out there are going to gain some insight into this and at least have their curiosity piqued and want to get started, or at least have a introduction to this to see if it would really benefit their organization. Ryan, thank you so much for joining us.
Yeah, thank you for having me.
All right, this closes our podcast today. Thanks for joining ADLINK and Amazon Web Services, and we look forward to more podcasts in the future. Thank you.